In this video, we're going to configure so-called Android virtual devices, which you can use for testing your Android apps as you develop them on your computer. And these are particularly helpful if you don't have actual Android devices on which to test your apps. And that's good for learning purposes. But if you do get to the point of developing real Android apps for placement into the Android market or other online markets, you will want to have actual devices on which you can test your apps to make sure, for example, that certain features work correctly. And the reason for that is the Android emulator, though it's very thorough, does not support all features of the different devices that are out there. So for example, if you really want to test a gyroscope that's built into your Android smartphone, you really need to put the app onto a real smartphone so you can shake it and move it around in real space as opposed to just have something on the screen. Now it turns out that there are some capabilities available from a website called openintents.org that allow you to simulate various device capabilities. So for example, there's an app called Sensor Simulator available from openintents.org, and it is capable of sending simulator events into an AVD so that you can simulate the concept of shaking the device or moving it around, etc. And separately, because Android is available for so many different devices that are running so many different versions of Android, you may want to set up lots of different Android virtual devices. So in order to do that, we're going to be working with the so-called AVD manager. And again, in the window menu here, you can see the AVD manager in Eclipse. In prior versions of the Android development tools, the SDK manager and the AVD manager were one tool. Now it's separate tools, as you can see here. So I'm going to launch the AVD manager, and here is where we will create Android virtual devices that simulate or emulate the different devices on which you want your app to run. And to create one, we'll start by clicking New, and we can give it a name. In our case, one of our primary testing devices was a Samsung Nexus S smartphone, so I'm going to name this particular AVD Nexus S. The next thing you do is specify which version of Android you wish to target with this device. Now my Nexus S happens to be running Android 2.3.3, so I'll select that version for this AVD. And then we have various other options as well. Now the AVDs support the ability to simulate an SD card. If your device has SD card capabilities or even built-in memory that's separate from the RAM, then you could specify that size here. But please keep in mind that whatever size you specify is going to be allocated as actual disk space as part of the AVD. So what I like to do typically is set it to 256 megabytes, but some of these devices can have many gigabytes worth of space, and of course SD cards can be quite large now as well. The next option is a option called Snapshot, which you should always enable. And basically what this does is it allows you, once you start running your AVDs, to save them in a running state so that they can be loaded directly back to that state later on, which often can be much faster than quote-unquote booting one of these Android virtual devices from scratch. When I first started developing in Android, AVDs were extremely slow, and they have come a long way, but overall they're still much slower than working with real devices, and for efficiency, snapshots are a great way to go. So we'll check off that option. Separately, we have the skin option, which basically allows you to configure the screen size for your device. Now, our particular device uses the WVGA 800 size, which is basically a screen that has 800 pixels by 480 pixels. And you can see that there's a number of pre-configured ones that are shown here. It doesn't show you tablet device sizes because Android 2.3.3 was intended for smartphones, not tablets. I'll do another AVD shortly with you where we'll configure it for Android 3.1, and at that point you'll see that there's an option for a larger screen size. You can also explicitly set the precise screen size if it doesn't match up with one of the predefined so-called skins. Now, in the hardware section, it does fill in a few options for me by default. We have the abstracted LCD density, and the particular device that I'm working on is a so-called high-density pixel device, 240 pixels per inch, if you will, for the Samsung Nexus S. And this information is part of the specs for each individual device. So if your device does not match up precisely with this and you want to be as precise as possible, you can click the value and change it right here. It also gives me a maximum virtual memory application heap size by default and a device RAM size of 256 megabytes. Some of these devices have gigabytes worth of RAM, but again, if you choose large sizes for your RAM, that will be allocated as disk space with the AVD, and if you're tight on disk space on your computer, you may not want to allocate that much space. Now, these are the default options. However, you can get much more precise about the features that are available to you in an AVD. For example, if you know that a particular device does not have a camera, you can click this New button, and there's lots of different options that you can specify, such as camera support. So if I go ahead and select camera support and click OK, you see it immediately inserts camera support no, which is the default. But in the case of a Nexus S, I actually do have camera support, so I can go ahead and select yes. And I can do that for lots of different options. Now, for my basic AVDs that I used in these videos, I did not add extra options. I just went with the default capabilities that are built into the AVDs. However, if you want to precisely mimic an actual device, you'll want to go to the specs for that device and see what all the features are that it supports, and then go ahead and add in as many of these options as necessary for your particular device. So I'm going to go ahead and delete that one option we added. I'm going to click Create AVD at this point, and now we have our first AVD set up and configured. Now, if you want to launch an AVD for the purpose of testing an app, you can select it from the Virtual Device Manager and go ahead and click the Start button. And I do recommend that you do this before you start developing, because again, sometimes launching AVDs can take quite a while. When you say Start, you'll get this Launch Options dialog, and you have a few different things that you can choose here, one of which is to scale the display of the AVD to an actual size. So for example, if you know that your device has a 4.3-inch diagonal screen, you can say so here. You can indicate what your monitor's dots per inch are, and it will scale the AVD to, as closely as possible, mimic the size of your real device on the screen. You can also tell an AVD to wipe out any user data that was stored by the various apps that you install into the virtual device if you would like. If you want to keep that user data, you make sure that this is unchecked. If you have previously run the Android virtual device and said in that previous run to save it to a snapshot, this second to last option will load the snapshot and bring the AVD up on the screen in its last available state. And if you check off Save to Snapshot, when you close an AVD, it will save the current state into a file on disk so that it can be launched from a snapshot at a later time. Now, as I get ready to create a couple of other AVDs here, I'm going to go ahead and click Launch so that that launches in the background, because I do want to show you some features of the AVD in a few moments. And while that's happening, let's go back over here to the Android Virtual Device Manager. Now, for the different apps that we use in our book, we actually tested on several different versions of the Android platform from 2.2 up to 3.1. And for that reason, we actually wound up creating several different virtual devices. So for example, a second virtual device we created was for the original Motorola Droid, which at the time of this recording was running Android 2.2. So I'm going to go ahead and select 2.2 for that one. And as I do in many of these cases, I set up 256 megabytes for an SD card. And in the case of the Motorola Droid, its screen size is actually 854 by 480. So I'm going to select the WVGA 854 skin. And then finally, it specified the abstracted LCD density and the VM heap size as well. And I'll go ahead and create that AVD. And separately, we had some apps that we did, or that we tested rather, using Android 3.0 and 3.1. Let's assume we just want to set up an Android 3.1 version of the emulator at the moment. So we have, for example, in-house here, a Motorola Zoom tablet device. So one of the AVDs that we set up was to mimic the Zoom. So I'll call that one Motorola Zoom. And at the time of this recording, it was running Android 3.1. So I'll select Android 3.1. The size of the SD card, again, I often use 256 just so I don't take up too much disk space. So I'll do that again here. The built-in resolution is WXGA, which is common for the big tablet Android devices. And again, it gave me some predefined hardware options, but I can go ahead and add as many or remove them as I need to based on the actual device capabilities. One thing you'll notice, by the way, for a tablet is that the LCD density is 160, which is a medium density device as opposed to a high density device. And the reason for that is you have the larger screen, but you don't have a corresponding increase in pixels that would allow it to remain at the 240 dots per inch at the moment. Over time, screens will get more dense and better as we move forward. So finally, I'm going to go ahead and create that AVD as well. So we've set up 3 AVDs for the purpose of testing apps in these live lessons videos. And the last thing I wanted to show you here is just some of the features of an AVD. So I'm going to switch over to my running AVD now. And this is the Nexus S AVD that's running Android 2.3.3. Now, depending on what type of device you have, you may or may not have various physical buttons on the device, and you will certainly have various so-called soft buttons on the device, such as the ones that you're seeing at the bottom of the screen here in my AVD. Now, over on the right side of the AVD here, we have a keyboard that we can use for interacting with text boxes in the device. So if I click in this search box, I could then type a search using the keyboard by clicking on the various keys using my mouse. All Android devices before Android 4.0 have home, menu, back, and search buttons, at least for smartphones. The tablet devices don't have those. Tablet devices that run Android 3.0 and higher have buttons that are similar to these that are built into the soft buttons on the screen. But home will bring you back to the home screen that you see on the AVD at the moment. Menu, if I touch that, is going to bring up a menu of various options for whatever app or screen I happen to be on at a given time. The back button will dismiss that menu or go back to the previous app, whatever that happens to be. And of course, the search allows us to search our device for various items. We also have buttons to emulate the concept of the camera, lowering and increasing the volume, powering the device on and off, answering a phone call, hanging up on a phone call, and this is called a D-pad. Some devices have pads like this that allow you to navigate through the graphical user interfaces on the screen. Now, this little dotted button at the bottom here will show you the list of applications that's already installed on the device, and you'll notice that we have the API demos that were provided by Google, and you can look at those demos to see various features in action. There's also a couple of key tools that are here. Custom locale. If you're developing an app that's going to need to run in many different locales, for example, an app that should be displayed in Spanish and French and English and other languages, you may want to be able to customize the locale so that you can ensure that your app displays the correct language strings in each of those different locales. You also have dev tools, which I'll click for a moment here, and these are various development tools that can help you out. So for example, if you want to add media files into an AVD, which we talk about in one of our later lessons, you can use the media scanner to then scan the device looking for those media files, whether they be audio files, images, or video files, and that way make them known to the AVD so that it can provide them to you for access in various apps. Let's go ahead and hit the back button here. And finally, we have how it is that we have to set up a device for the purpose of real development on an actual device. Now I'm going to demonstrate this to you in the context of an AVD, but if you have a real device that you would like to hook up to your computer and load apps onto it for testing, you're going to need to do the following on that device. You're going to go to the Settings app, then you're going to go to Applications, and within Applications you'll see this Development option. Now, because I'm in an AVD, which is specifically meant for development purposes, you'll notice it already says USB debugging checked. When you hook up an Android device to your computer for development, it's typically hooked up via a USB port on your computer. And in order to allow the device to communicate with the Android development tools, you must enable USB debugging. This also allows you to get information from the device into the debugging tools and the DDMS tools so that you can check to make sure your app is working correctly, or if your app crashes, so that you can get the stack traces that indicate what the problem was and what the error messages were, etc. You can also tell your device to stay awake during the debugging purposes so that it doesn't go to sleep while you're in the middle of doing something with an app, and you can also tell it to allow so-called mock locations for location-based app testing. So at this point, we've now set up the development environment to allow you to get ready for Android development, and you're now ready to proceed with Lesson 2, where we'll start to talk about how to interact with an app by loading it into the Eclipse IDE, installing it into an AVD so you can test the app, and then after that we'll proceed with lessons where you actually start building your own apps.